Alright, so question 5, page 210, basic physics problem. The position function of the particle is given by the equation s equals t to the third minus 4.5t squared minus 7t for all values of t being greater than 0. So, basic. Now, I somehow lost a slide where it said the part of the problem, the actual prompt, but the prompt is, when does the particle reach a velocity of 5 meters per second? So that's basically asking us to find the derivative of the position formula, which is the velocity formula, which I have here, 3t squared minus 9t minus 7, and it's asking us to find when that graph is equal to 5 for values greater than 0. So here we have the first step, and we have the velocity formula equal to 5. And here we have the actual full equation, with all the values moved over to one side and having 0 on the other, because here we're going to, we have a quadratic formula. We have a quadratic equation, sorry. We can factor it. So you can find how to factor it whatever way you wish, but at the end of the day we get 3t plus 3 equals t minus 4 equals 0. So now we just have to break off these two parts into each part equals 0 on its own. And we get these two parts. So basically we're going to move all the non-t values over one side. You guys know this already. I won't patronize you with the details. Basically we get, t might equal 3t equals -3, t divide both sides by 3, t equals -1, and on this side just moving over that, 4 over to the other side, so you get t equals 4. Now, since the equation was only pertaining to all values more than 0, or more than greater than 0, t equals -1 does not count, and so the only value that does is t equals 4. So second part of the problem is when is the acceleration 0, and what's the significance of the value of t at this point? So, it doesn't say at the point, but it's implied. So when this is basically saying so the derivative of the velocity formula is the acceleration, which is basically saying how fast is it going, how much faster is it going at that point, and here we have it. So I just rewrote the velocity formula, 3t squared minus 9t minus 7, and then you use the power rule again here. So we bring it over to here, and it becomes 6t, and this becomes 1. Carry over the 1 multiplied by 9, and just gets 9. And since the derivative of a constant is 0, you get 0 for there, and you have to include it here. So this is the acceleration of s, how fast it is accelerating at the point of t. Now, it was asking for when is the acceleration 0, or when is it maintaining a constant instantaneous speed at a single point. Well, then you just set the entire thing to 0, and you bring over the 9, as I've done already here. Not so sorry about the blurriness in the other slides, that's your problem. But then you take, to get t alone, you divide both sides by 6, and you get t equals 9 over 6, or, written fully, is 9 over 1/2 seconds at the point of 1.5 seconds. Now, like I said, this problem didn't mention what kind of significance they're looking for, so I actually checked the back of the book because I had a different answer from the one that they had, but the significance that the book is looking for, and I'm supposing the APP test might be looking for, is the significance of s at that, or the significance of t at that point, is it shows that s has a minimum velocity, or I suppose, yes, a minimum velocity, since that's the lowest point of acceleration, and therefore it would have to be on the rise with the rest, or it could not go past that point.